So now let us consider one more example. So here we have to find the domain of f of x, where f of x is square root of logarithm of x minus 4 to the base 3, right? So in order to find out the domain of this function f of x, let us here draw the real number line that is from minus infinity to infinity, right? So here we see that we have the square root sign, and here we have this term x minus 4. Now see, the first condition to define the domain of this function f of x is that this expression, that is x minus 4, it should be greater than 0, because x minus 4 should not be a negative quantity, because the logarithms of negative quantities are not defined in the set of real numbers. So x minus 4 should be a positive quantity. So if we solve this inequality, we'll get x greater than 4. So let us represent this inequality x greater than 4 on this real number line. So here we have the number 4, and let us draw a circle over here, and it implies that x is equal to 4 is not included, so it is excluded. So now we have x greater than 4, which implies x belonging to this interval, that is 4 to infinity. So here we have this region, right? So now let us see this square root sign. So now consider this entire term, that is log of x minus 4 to the base 3, which is under this radical sign, that is the square root sign. Now see, the second step is to define the domain of this function f of x, is that this term, that is the log of x minus 4 to the base 3, it must be greater than or equal to 0. So this term, that is logarithm of x minus 4 to the base 3, must be a positive quantity, or it is equal to 0 in order to make this function f of x a valid function, right? Because the square root of negative numbers are not defined in the set of real numbers, right? Okay, so now we have to solve this inequality, right? So we have to find all the values of x which makes this inequality valid. So in order to solve this inequality, we'll make use of the property of the general exponential function, that is y is equal to a raised to x, where a is greater than 1. And we know that this exponential function is an increasing function, right? So now to solve this inequality, we'll raise both these terms, that is log of x minus 4 to the base 3 and 0 to the power of 3, because the general exponential function y is equal to a raised to x, where a is greater than 1, is an increasing function, right? So we'll write 3 raised to a log of x minus 4, and here we have the base 3, and here we have 3 raised to 0. So now here 3 raised to log of x minus 4 to the base 3 is simply x minus 4, because we know that if we have a raised to a log of say f of x to the base a, then this is equal to f of x, right, where a is greater than 1. So 3 raised to log of x minus 4 to the base 3 is x minus 4, and here 3 raised to 0 is 1. So now we have a simple inequality, so we can take minus 4 to the right hand side, so we have 1 plus 4. So x should be greater than or equal to 5. So let us represent this inequality on this real number line. So now 5 is somewhere here, and here 5 is included, and x greater than or equal to 5 is given by this reason. That is x greater than or equal to 5 is given by x belonging to the interval 5 to infinity, right? So now the domain of this function f of x is the intersection of this interval and this interval. That is, domain of f is given by 4 to infinity, and here we have the intersection, and here we have 5 to infinity. So the intersection of these two intervals, that is given by this interval, that is 5 to infinity. So the common region is from 5 to infinity, where 5 is also included. So we have 5 to infinity, 5 is also included. So the domain of this function f of x is given by this interval, that is 5 to infinity, where 5 is included.